Hey folks, welcome to Professor Smartycorn's video tutorial on how to count the particles in an atom. Okay, so here's how to figure out what is inside an atom and how many of each type of particle there are. Now first up, I want to point out that in the nucleus of every atom, there are protons and neutrons. Okay, the protons and neutrons are found in the nucleus. Okay, the electrons are found outside the nucleus. They are orbiting or buzzing around or zipping around the nucleus. Okay, now one thing to point out, these protons and neutrons that are in the nucleus, they are not always equal in number. In this carbon atom, they happen to be equal in number, but that doesn't always have to be the case. Okay? One thing that does always have to be the case, though, is that the number of electrons, in this case 6, has to equal the number of protons. Why is that? Well, that's because the number of negative charges have to equal the number of positive charges, so they balance each other out, because all atoms are neutral overall. So those 6 negative electrons are balanced out by the 6 positive protons. Okay? Another important thing to remember, if there are 6 protons, you know it has to be a carbon atom. The number of protons, also known as the atomic number, that defines what type of element or what type of atom you've got. Okay, so the number of protons, that's also known as the atomic number. We'll come back to that. All right, atomic symbol notation that you will sometimes see. This X basically just is the element symbol that you can get from the periodic table. Z, that's the atomic number, which is the number of protons. And A up there, that's the mass number. The mass of the things with mass that are in the nucleus, the number of protons plus the number of neutrons. So the mass number is just the number of protons plus the number of neutrons. Okay. Now remember, the atomic number, the number of protons, that uniquely identifies an element. So we might look at this example over here. Na is sodium. Okay, yes, it's a weird symbol for something that starts with an S, but Na is sodium. Okay, what do we know about it? Well, it has 11 protons because its atomic number is 11. It has 23 neutrons and protons total because its mass number is 23. And it's got 12 neutrons because we can just take the total of neutrons and protons, subtract the protons, that's 23 minus 11, to get 12 neutrons. So this particular atom of sodium has 11 protons and 12 neutrons, giving it a mass number of 23. All sodium has an atomic number of 11. Okay, that's what defines sodium as an element. That atomic number tells you you've got sodium. If it were a different atomic number, it would be a different element and a different symbol. All right, now your periodic table is a little bit similar to this kind of notation. What's the same? Well, the element symbol that's given in your periodic table is the same as the element symbol in this kind of notation. The atomic number happens to be in the same place, the lower left corner, in your periodic table and in this kind of notation. Okay, this number right here, though, on your periodic table with the decimal, that's the average atomic mass, and we'll talk more about that later when we talk about isotopes. So today, just want you to focus on the atomic number and the mass number that is given for a particular atom. Don't worry about this average number for today. All right, let's try practicing filling out a chart. This is basically like doing a puzzle. You take the information that they give you, you take the clues that they give you, and you see if you can figure out various other pieces of information that are missing. Now, really important to remember, the atomic number, that defines what element you have. And the atomic number, by definition, is the number of protons. If you know the atomic number, you immediately know the number of protons. Okay? If you know the number of protons and the atomic number, you know, oh yeah, I have oxygen. Okay? But the next thing that you can immediately get is if you have 8 protons, well, you have to have the exact same number of electrons. So the protons and electrons are always equal in number because they have to balance each other out. These positive protons balance out the negative electrons. Okay? And the atomic number 8, which is the number of protons, tells us we have oxygen. Let's try the next one right here. We've got an atomic number of 7 and 7 neutrons. Let's start with the atomic number. The atomic number immediately tells you you've got 7 protons. Okay? And that also then lets you immediately say, oh yeah, I've got 7 electrons to balance out those 7 protons. Okay. Now we can also then look at the number of neutrons and the number of protons. Oh yeah, the mass number is the protons plus the neutrons. So that 7 protons plus that 7 neutrons gives us a mass number of 14. That's 7 plus 7. Now we can go back and fill in this early parts that we skipped over. We know the atomic number is 7, so we can look on our periodic table and figure out, okay, which element is in the 7th box on the periodic table, the box with a atomic number of 7. That would be nitrogen. Okay? And now this notation shows us that, yes, nitrogen has an atomic number of 7. That's all nitrogen. And in this particular case, this isotope of nitrogen has a mass number of 14. Okay, the mass number of this particular atom of nitrogen is 14. Some other nitrogen atoms may have a slightly different mass number because they can have differing numbers of neutrons. The protons are always the same for a given element. Let's try the next one. We've got the symbol notation with S and an atomic number of 16 and a mass number of 34. Okay? There's a place where you can turn element symbols into names. It's table S on your periodic table. That's the big list on page 10 and 11. So that immediately tells you, oh yeah, S is sulfur. Okay, and now right here we've got the atomic number given down here. It's also given on table S. Okay, so we know the atomic number is 16. That immediately tells us we've got 16 protons. And if we have 16 protons, we have to have 16 electrons to balance them out. Now we're just about done. We just need the mass number. It's the protons plus the neutrons. 16 plus 18 makes 34. Next one, they give us the atomic number right here. So we can immediately say, oh yeah, so that means there's 1 proton if the atomic number is 1. And if there's 1 proton, there must be 1 electron because protons have to equal electrons. And now, next up, we can say that, oh yeah, the protons plus the neutrons, the 1 proton plus 1 neutron gives a mass number of 2. So that's by definition, that's what the mass number is. Now we can go back and fill in the early parts. If it's got an atomic number of 1, you look on your periodic table, what's the first element? Well, it's hydrogen. How do we write that symbol? It has an atomic number of 1, but its mass number is 2. This particular isotope of hydrogen has a mass number of 2. Some hydrogen isotopes have different mass numbers because they can have different numbers of neutrons, but the protons are always the same. Finally, let's do this last one. It's got an atomic number of 12. That immediately tells us that it has 12 protons. That's by definition. We know that protons and electrons have to balance out. 12 positives have to balance out 12 negatives. Then we can figure out that since our mass number is 24 and there are 12 protons, well, 24 minus 12 means there must be 12 neutrons. Now we're ready to figure out the element and write its atomic symbol notation. 12 on your periodic table, the 12th box, atomic number of 12 must be magnesium. You find it in the 12th box on your periodic table. The symbol is Mg. The atomic number is 12. But then the mass number of this particular atom of magnesium is 24. But that mass number was given to us right over here. Okay. All right, that's the end of this tutorial. Thank you for watching and listening.